Saxon Algebra 1, Lesson 20. Our topic today is volume. So this is a geometry lesson. We have reviewed perimeter, which is a one-dimensional idea, right? When we measure perimeter, we're just measuring a line. We've also studied area. Area is two-dimensional. And when we study that, we're studying like the space within a shape, right? This would be the area of a rectangle, right? Today we're studying volume. And volume is a three-dimensional idea. It's the most fun to draw, right? Because we can draw cool three-dimensional shapes and practice making them look as three-dimensional as possible. Volume is fun because there's only one simple formula to remember. Make sure you write this down where you write your formulas. It goes, well, it doesn't go without saying because I'm going to say it, but from now on, it goes without saying, if I write down a formula and put a puffy cloud of knowledge around it, you need to memorize it. Anything that I'm puffy cloud, you need to memorize. To find the volume of any shape, you find the area of its base, and then you measure it by its height. Yay! It's so simple, right? So we just take area, everything we know about area, and then we're just multiplying it by one more dimension. Now, here's both the cool thing and the annoying thing. Our bases, our volume formula never changes. But the area of our base could be a rectangle, it could be a triangle, it could be a circle, it could be a half circle, it could be a bunch of those things put together. So when we do these problems, we kind of have to be ready for anything. Let's try one, shall we? Let me see how many examples there are. 1, 2, 3, 4, 5. But the last two are super fun. They're kind of like not a trick, but they're like a fun surprise. Okay, example 19, or 20, rather. I'm making us go back to roots and powers. A base of a right prism is the isosceles triangle shown. Okay, let's take a look at the picture. I'm going to draw it for you. Because why not, right? It's like a wedge of cheese. Like in the song, The Farmer in the Dell, the cheese stands alone. This cheese is standing alone. It's a wedge of cheese. And that's what John says. The base of this right prism is an isosceles triangle shown. He also has a picture that looks like this. Only it's more perfect. Mine's kind of doesn't look like they match. Copy all this down. I'll give you a minute to catch up, and then I'll explain what John's saying. He's saying that this three-dimensional object, which is called a right prism, don't let those words freak you out. That just means nice, perfect, three-dimensional object. He's saying that the base of this, ooh, pretend that's perfect. The base of it, right, is a triangle, and this is a map of that triangle. The top is exactly the same too, but he's saying top and bottom, this is what that looks like. He also tells us that the height of the prism is 8 centimeters. Okay, that's right there. Oh no, so the height of the prism is 6 centimeters, sorry. Okay, so that's this measurement. That's the 3D-ness of it. Find the volume of the right prism. Okay, our formula is find the area of the base and then multiply it by the height. Okay, this is the base. And this is the way the problems usually work, is that we get a special map of the base with detailed information that allows us to find the area of the base. All right, I'm sold so far. How about you? It sounds really fun. Then once we figure out the area of the base, all we have to do is multiply it by the height, which is right here, and we'll be done. All right, how do we find the area of a triangle? Area of a triangle equals base times height divided by 2. Make sure you have that memorized. Now we plug in our numbers. The base of our triangle is 4, the height is 8, and we divide by 2 because that's just how one does for triangles. That means our answer here equals 16, and this is centimeters, but I'm not going to worry about the units until the very end. Okay, so the area of the base is 16. Aha! Now the volume equals area of the base times the height. Okay, the area of the base is 16, and the height is 6. And that is 96. I can do that in my head. 6 times 10 is 60. 6 times 6 is 36. I add 90 and 36, and I get 96. Now I'm ready. Centimeters cubed. Volume is always cubed because volume is a 3-dimensional measure. The exponent always matches. Area is always squared. Perimeter is just plain. Okay, that was a fun example, wasn't it? So far, so good. Let's make it harder. Oh, sure, why not, right? That sounds fun. Example 2. This one is still not bad. It's not until the third one that John pulls out the stops. Okay, the base of a right prism, 8 meters high, is shown. This time I'll just draw you the picture because I don't want to try and draw that. Okay, so he's saying this is the right prism. Again, that just means when you hear right prism, just think simple 3-dimensional shape. All right, you don't have to worry about that word. Those two words don't have to scare you. Okay, so this thing is 8 inches high. So there, right there is our information about how high it is. Find the volume of the right prism. Dimensions are in meters. So once again, we get a map of the base. That is the way these problems will just about always work. So we know our formula. Volume equals area of the base times the height. Okay, I'm going to put that there. Now I'm going to draw my map of the base. This part we need to draw. It's not that important to draw the 3-dimensional part, but we definitely want to draw this. Pretend mine is perfect. It's clearly not. Okay, so we look at this thing and go, what the heck have we got here? What is this monster beast? Again, this is the base of our shape, so we want to find the area of this. And I can see, oh look, we can turn it into a rectangle and a triangle. So we need to find the area of that, but we're quite accustomed to this. So first we'll find the area of the rectangle. That formula is length times width. That would be 6 times 4. So it would be 24. I don't need my unit yet, but at this point I think, oh yeah, what is my unit? Oh, it's meters. Okay, I'll write that down for later. Area of a triangle. That's a different formula. We just use that one though. Base times height divided by 2. Make sure you can just toss these off in your sleep. The base of our triangle, this much is 4. This much is 10, so just this much of it must be 6, right? The height of our triangle is the same as this, so it's also 6. Divided by 2, 3, I cancel, and this is 18. Okay, so that means our total area is 42 meters squared. That's the area of the base, right? So I'm going off of this. The height usually is just written in the word part of the problem. or sometimes it might be shown on the picture of the right solid, but usually it's in the words. The right prism is 8 meters high. So H equals 8. And honestly, I usually like to write that up here at the beginning. That's what I would do. And then we're going to multiply by H, and we can just do our work right here. 336 meters cubed. Volume is always a cube. Oh, do you feel smart? That's kind of moderately hard. It's going to get harder now, though, and then it's going to get easier. You ready? 20.3. I need a fresh page for this. You guys, I highly recommend the power of the fresh page. If you're feeling annoyed with your homework and you have to keep going, but you just need a new, fresh start, just flip over. Just go to the next page. It feels so much better. The base of a right solid, 10 kilometers high. Okay, that tells me we're working in kilometers. 10 kilometers high. That tells me the height is 10. Find the volume of the right solid. Dimensions are in kilometers. All right, that's just John giving me the same general instructions for finding the volume. I'm not going to copy the picture, but I take note of it. It looks kind of like an old-fashioned mailbox standing on its side, right? This is what I need. I need this because this is where I'll find the area of the base. Multiplying by the height is easy. It's the area of the base that is a bit of work. So I'm drawing it, and I really appreciate the way John has drawn it because he put in the little dot, dot, dot for me. Sometimes I have to figure that out myself. And we can see that this base is the classic rectangle with a semicircle. All right, we've been down this path before, right? We know how to do this. This we're familiar with. Really, all that we have to do for finding the volume is do our area of the base business and then just multiply it by the height. That's all that's different. All right, so to find the area of this base, we can see, okay, we've got a rectangle. That's length times width. That's 6 times 5, right? Which is 30. Now we need the area of the half circle. And I always draw that because it reminds me of what to do with the formula. The area of a half circle is the area of a circle, pi r squared divided by 2. Pi is 3.14. R is 3 squared divided by 2. All right. Now, I'm just sitting here thinking about the simplest way to simplify this. I can tell this much is 9, right? I don't want to do 2 separate steps. I don't want to multiply and then divide. So I have some choices. I could multiply 3.14 by 4.5 because if I take 9 and divide it by 2, that's 4.5. I could do that. I'm okay with that, but this might sound silly, but then I'm multiplying decimal number by decimal number, and that just doesn't feel like fun to me. So I say, what if I take the 2 and divide it into 3.14? Could I do that easily? And I realize, oh, I think I could because 2 divided into 3 gives me 1.5, and 2 divided into 0.14 gives me 0.07. I'm just cutting each of those numbers in half. So that tells me that that tells me that 3.14 divided by 2 equals 1.57. I can take 1.57 and multiply it by 9, and my work is done. If that all confused you, you can just multiply 3.14 times 9 and then divide it by 2. I'm just showing you a way that you can make it a little simpler. 45, 51, 1, 2. I'm just multiplying that out. this then is the area of half a circle. And I'm going to give that one decimal places so they match. That is the total area of the base. And now all I have to do is multiply it by the height, which is 10. And I know that just bumps the decimal place, doesn't it? So my answer is 441.3 kilometers cubed. That's the right answer. Yay, team. Yay, team. Okay, that's probably the hardest problem that we're going to do today, but we have 2 more to do. Example 20.4. A right circular cylinder has a radius, blah, 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 blah. Let me show you the picture. Look, it's like a little can of evaporated or condensed milk. Do you know what I'm talking about? It's like an individual serving size of baked beans. It's a cute little mini can. I like it. It's a individual size can of Pringles. Although I think that's a misnomer because I think the full size can of Pringles is an individual serving as well. I used to eat, one of my daughters lived in Asia for a number of years, first in Vietnam and then in South Korea, and I used to go and visit her, and obviously the flights are a bit of a haul, and I would always buy the cheapest flight I could and end up with long layovers, and Pringles were like the best thing in the world to me whenever I was laid over in an Asian airport. Shanghai, Taiwan, you name it, just crazy places. Singapore, I had to wait 24 hours. No, 12 hours, but I had to do it going and coming, so I ended up 24 hours total. Pringles are the best thing to eat in an Asian airport, trust me, and if you ever find yourself there, buy Pringles. But don't buy the little cans, buy the big ones. Anyway, this is our shape. Now, because this is a relatively simple shape, John's not giving us the separate map. We have to figure it out ourselves, but he's kind of drawn it for us a little bit right there. Okay, so this one we have to think a little bit harder, but the problem's actually easier. All right, so our shape is like this, right? I'm just gonna kind of simply draw this. But I'm drawing the bottom of it because we know that volume equals the area of the base times the height. So this is my own little map of the base. John didn't tell me, so I'm gonna figure it out. The radius is 6, good to know. And the height is 11, as shown. John points out, because he showed it on the picture. Let me just show you. See, that's how John can show height on the picture sometimes. All right, he put it in the words and the picture this time. Find the volume of the right circular cylinder. The reason this problem is easier is because the area of the base is just a circle. It's not multiple shapes smushed together. So the area of the base will equal the area of the circle, which equals pi r squared, which equals 3.14. Sometimes I write 6 squared, but sometimes I just skip over that step and go right to 36. Make sense? Do it whichever way you like. If you feel like it's too big of a jump to go from this picture to 36, go ahead and write 6 squared, but you'll get there soon enough, right? Okay. Now what we have to do is multiply these two together to get an actual number. Oh, the other thing I want to do is write down our units. Inches. Okay. 3.14 times 36. I'm making a work area right here. Ah, wiggly work area. 6 times 4 is 24. 6 times 1 is 6 plus 2 is 8. 6 times 3 is 18. Yay. 0 goes there. 3 times 4 is 12. Put down the 2, carry the 1. 3 times 1 is 3, plus 1 more is 4. 3 times 3 is 9. 4, 0, carry the 1. 3, carry the 1, 11. And I've got 2 digits behind the decimal place in the factors, so I need to put the same in the answers. Okay, so that tells me the area of the base. I'm just going to write it over again. I don't want to squish it there. Equals 113.04 units, blah, blah, blah. But we don't need to do that yet because we still have to multiply by the height, and the height is 11. And I set this problem up so that we can calculate it right here. And everything's fine. This is all times 1, so I know it's going to be 40311. And then I put the 0 here, and then I'm going to do the whole thing again. 40311. So the multiplying is pretty easy. Multiplying by 11. So my final answer is 4, 4, 3, 4, 2, 1, and I have 2 decimal places. So it's 1,243.44 inches. Volume is always a cube, cubed. Oh, yay. That was easier than the other ones because we didn't have to do complicated steps to find the area of our base. It's just a circle. Pringles, keep it in mind. All right, last problem. Are you ready? Are you pumped? Are you psyched? Because I am. This problem, when you look at it in the book, you groan and you go, oh, this looks really hard. I don't know how to do this. Why is my mom making me take stupid algebra? I hate it. Don't worry, it's not bad. This is the picture though. See what I mean? You look at this and go, man, this is some weird skyscraper I've seen somewhere. But it's not a problem I want to do because that looks like a really hard shape. And how would I even do that? There's a circle. I don't know what to do. But then I read the problem. The base, a base of the right solid has an area of 52 feet. Wait, what? They're telling us the area of the base is 52. The height is 15. Find the volume. We don't have to calculate the area of the base. John's just giving it to us. The area of the base equals 52, and we're in feet. The height equals 15. He gives us that as well. All we have to do is multiply them together because the volume equals the area of the base times the height. I need to write it one more time. If my wrist falls off tonight, I'll know I wrote it one time too many. But remember, I want you to be able to see your formula on every page. So if you're working multiple volume problems on the same page, you don't have to keep writing it over and over as long as you can see it. But when you flip to a new page, you have to write it again. Okay, ready? I'm going to multiply. And I'm just going to multiply right here in my calculation. 26. I put a 0 down, and then it's times 1, so it's just a 2 and a 5. 0, 8, 7 feet cubed. That's my answer. So, do you see what I'm saying? If John gives you a really, really wacky shape that looks impossible to figure out the area of, read carefully because he's probably just going to tell you the area of the base. And let me just see, does he do that? Yes. Well, it's 30, so you won't do it. But that one, see, he just gives you the base. It says, oh, it's 45, don't worry about it. You can trust me. Oh, he does it here in C. Remember, I'm asking you to do all of the practice and then the odd numbered problems. But you'll need that same trick here. A base of the right solid has an area of 50 centimeters. Done. The height is 12. Area of the base times the height. There you go. Yay. That's a nice way to end a lesson, isn't it? Is with a problem that is so simple that you just want to click your heels and dance for joy. So I invite you to do just that. I'm going to teach some more algebra to the Algebra 2 students. That's my way of clicking my heels. And dancing with joy is to teach more algebra. Okay, I'm done. Goodbye.